Welcome to the 4.3 converting by completing the square when a does not equal 1 notes. So what we're going to do in this section is we're going to take a function that is in standard form, in the form of ax squared plus bx plus c, and convert it to vertex form. And we're going to do that by using the complete the square method. Okay, so the first thing we're going to do is you're going to divide everything by your a term. In this first problem, it's actually a greatest common factor. If you look at all three of these terms, they're all divisible by 7. So what I'm going to do here is I'm just going to divide every single thing by 7, and instead of making that 7 like go away, so to speak, you're going to put it on the outside of some parentheses. So what's left is x squared plus 4x plus 8. Okay? And I guess don't forget your f of x, right? So you want that 7 on the outside because you don't want to technically like change anything, so to speak. If you were to distribute this, it would go right back to the original, okay? So if you were to work this problem out backwards, it always goes back to the original. So anyway, I'm going to focus my attention now on what's left in the parentheses, okay? So I'm going to move the 8 over. I'm just going to give it some space because now we're going to add in our our b over 2 squared term. And just like we did in the convert by completing this square, when a equals 1, you're going to add and subtract in that b over 2 squared term. So my b term here is 4, right? And so I'm going to do 4 over 2 squared, and then I'm going to minus 4 over 2 squared. Okay? And so I'm going to group these outer two terms together. Before I do that, though, I got a little ahead of myself. I'm going to put that 7 on the outside. Like I said, it stays on the outside the entire time. Okay? So I'm going to group those outer two terms together, and then I'm going to group these inner three terms together. So I'm going to have that 7 on the outside, 7 parentheses, and then I have x squared plus 4x plus 4 divided by 2 is 2, 2 squared is 4, so plus 4, and then I'm going to have, I'll put a little gap, minus 4 plus 8, okay? And now we are going to of x equals, I feel like I have to write that each time. And so we're going to factor this, what is the perfect square trinomial pattern for these three terms. So in other words, what are the factors of 4 that add up to 4? That's 2 and 2, right? So I can say 7 parentheses, and then I have x plus 2, and then what's negative 4 plus 8? That's going to make a positive 4, isn't it? Okay, and close the parentheses. All right, so instead of writing x plus 2 times x plus 2, we can say x plus 2 squared, can't we? So I'm going to say x plus 2 squared plus 4, and that's surrounded by parentheses with the 7, and it has an f of x equals. Okay, so at this point, you can call this your final answer. The double parentheses is important here. So like if you were typing in this answer in Schoology, you would do f of x equals 7 parentheses, then parentheses again, x plus 2, and then this would raise it, that symbol would raise it to the power of 2, and then you'd put plus 4 close parentheses. So that's how you type it into Schoology. Now, if you didn't want to do the double parentheses, um, you would do you would distribute the 7 to the 4 only. And so you could write this: f of x equals 7 parentheses x plus 2 squared. And then 4 times 7 is 28, right? So all I have to do is typing that into Schoology is f of x equals 7 parentheses x plus 2. And then I believe it is shift and the number 6 gives you that symbol. Raised to the power of 2 plus 28. Okay? So either this or this is acceptable for my final answer. I just want to make sure you all type it in correctly. As with do in this section, you can always check your work by graphing. So here I graphed the original equation and then the two acceptable final answers. And you can see there's only one graph here. That's because all three of them overlapped. Okay? And I almost forgot to identify the vertex. So anytime we convert it to vertex form, I'm going to follow up by asking you, where's the vertex? Okay, so it's easier to identify the vertex when it's in the green form. So the x-coordinate is at -2. Flip the sign on the inside, because the formula says x minus h squared plus k, and k would be 28. All right, and so if you were looking at the original form, or not the original form, but the non-distributed form, you would just have to know to do 7 times the 4. Um, I the best reason I can think of as to why you wouldn't distribute the 7 times x plus 2 squared is you'd first have to distribute x plus 2 squared and turn it into that, and then you would turn it into that, and then you would go, I guess you would go backwards. The only time you could distribute the 7 is at this step. You would have to go all the way back there in order for distributing the 7 to make sense, I guess. So that might be a bit of an over explanation. So however you want to type in your final answer for the equation is fine with me. Just know that it's easier to identify the vertex if you end up distributing the outside number to that outside term. And as always, check anything by graphing. And so here I went ahead and it's the same graph, but I labeled the vertex. And so there it is. Okay, for this next example, I'll put a fraction for the a value. You're going to treat it just the same as anything else. You'll divide everything by 2/3, so that'll be the number outside of the parentheses. Um, and, to make the math easier, I like to tell kids, instead of dividing by it, multiply it by the reciprocal. It makes the mental math part easier. So if I multiply 2/3 times 3 over 2, I'm left with 1x squared. And then if I could do -12 divided by 2/3, or I'd get the same exact answer if I did -12 times 3 over 2, which in my head, -12 times 3 is -36, divided by 2 is -18x. And then 22 times 3 over 2 would make 66 over 2, which is 33. Okay? And if I completely lost you there, just, hey, divide each of these terms by 2 over 3. Just make sure when you type it into a calculator that you divide by 2 over 3 inside parentheses so it does the order of operations correctly. Okay? Okay, so the next step would be to move that 33 off to the side, and then we're going to add and subtract in our b over 2 squared term. So our b term would be -18, and -18 over 2 would make -9. -9 squared makes 81. So I'm going to add in an 81 and subtract in an 81 and bring the rest of the equation down. So the next step would be to factor the first three terms and then just combine the outer two terms. So what are the factors of 81 that add up to negative 18. And remember, this is a perfect square trinomial, so use the square root of 81. The square root of 81 is plus or minus 9. I'm going to use a minus 9 because the middle term is a minus 18x. And if that confuses you, just think, hey, the factors of 81 that add up to negative 18 are negative 9 and negative 9. So I can say x minus 9 times x minus 9, and then negative 81 plus 33, what is that, like negative 48? And close these parentheses. I forgot a parentheses right there. And so bring down the f of x. Okay? And then just combine the two x minus 9s to make x minus 9 squared. And as I said in the previous example, this would be acceptable for the final answer. However, you may want to distribute that 2/3 just to the negative 48. And 2/3 times negative 48 would be negative 32. So I would also accept this for your final answer. That way you don't have to remember to do the double parentheses thing. And also it makes it easier, that much easier, to identify the vertex. The vertex would be at, since it says x minus h in the formula, then you'll flip the sign, so h is 9, and which is the x coordinate of the vertex, and k, it says plus k, so you don't flip the sign on the outside. So the y coordinate of the vertex is at negative 32. And as always, check your work by graphing it. So here I have it graphed in Desmos. I have the original, I have the answer that I wrote in red, and then the answer I wrote in blue. And you can see here I have the vertex labeled. So everything's lined up as it should be. They should all overlap. So yeah. Okay, so for my final example, I needed to pre-solve it to save some time because this video is already running long. Um, so here I have 3x squared plus 7x minus 11. I'm going to divide everything by 3, and then it's just going to make a bunch of fractions, okay? So don't get scared. Just approach it the same exact way you've been doing the other problems, okay? So when I divide out the 3, it's going to leave behind x squared plus 7 over 3x minus 11 over 3. So move that minus 11 over 3 to the side and introduce your b over 2 squared term. So that would be 7 over 3 over 2 squared. Add and subtract it in. And so 7 over 3 over 2 makes 7 over 6. And 7 over 6 squared makes 49 over 36. And so that's how I got the plus 49 over 36 and minus 49 over 36. You'll notice everything is exactly the same right here. Okay, so then I guess I factored the first three terms. And so what are the factors of 49 over 36 that add up to 7 over 3? Um, I I mentioned this in previous notes. When people get confused, particularly on the fraction part, just look at the step above. Before you square this number, this is what will be inside here. So when I said 7 over 3 over 2 made 7 over 6, that's what's going to go in here. 7 over 6 times 7 over 6 makes 49 over 36. And then 7 over 6 plus 7 over 6 makes 7 over 3. Okay? And so, yeah, so these first three terms turned into x plus 7 over 6 squared. And then I just combined these, minus 49 over 36 minus 11 over 3, and that made minus 181 over 36. And with the other examples, I'd be cool with this being your final answer. Just make sure you have the double parentheses at the beginning, okay? But as I mentioned before, it's easier to identify the vertex if you distribute that a term all the way to the back term, right? So do 3 times negative 181 over 36, and you're going to get 3, I'm sorry, you're going to get just negative 181 over 12, okay? That's the result of multiplying negative 181 over 36 times 3. So that means your vertex will be at, flip the sign on the inside, not on the outside. So negative 7 over 6, because flip the sign on the inside. And then comma, negative 181 over 12. And If you want to get the decimal approximation, hey, just type those into a calculator. It's approximately negative 1.167, comma, negative 15.083. And then as with all of this, always check your work by graphing. So here I have the original, the final form that I said, hey, that's okay with me, but you might want to just go ahead and distribute the 3 to the negative 181 over 36 to get negative 181 over 12. They all make the same graph. And then when you look at the vertex, it gives it to you in decimal form, whether you're using the TI Inspire or the Desmos graphing calculator. So over here on the side, I just typed in my fractions, and you can see they make the exact same thing. So now you know I didn't mess up. Okay, so I hope you learned something from these notes. Thanks for watching, and goodbye.